All right. Hi, everyone. Hope you enjoyed your networking session. Right now, I am going to, it's my pleasure to Darren Arthur from Nautilux Canvas in New Jersey. And Darren is going to be presenting on next generation technology. Let's take it away, Darren.
All right. Hi, everyone. Thanks for joining. So today, what I thought we would go over, for some it might be a repeat, but we're going to try to just touch base on some of the technology that's out there, how we've implemented it, some of the pros and cons, and then to show you guys a little bit of some basic starting foundations, so that for those that are considering technology or just getting started, to basically start with some good practices, a good approach. So is everybody, I guess, familiar with, I should also say, if while going through this presentation, if anybody does have any questions that I'm not describing very clear and you want more clarification, just send Charlene a note, and then she will pop on and ask me the question, then I can answer that to get that information to you.
You can do that in the Q&A section. You can just type your Q&A, your question in there, and I will relay it to Darren.
Okay, great. Thanks, Charlene. So when we started looking at technology, and really what it was is implementing CAD and implementing some cutting systems into our business here, what we looked at is what Mike Erickson actually had initially, which was a photogrammetry system. And that's using a software called Photo Modeler and a simple camera in the sky, sort of say. And really what you're doing is you're able to go about your regular daily business, pattern like you would traditionally, but when you come back, you take a photograph of your pattern, and then in the computer, using Photo Modeler, you would, in essence, trace over your pattern.
Darren, can you turn your volume up, please? Is there a way to turn up your microphone? People are having trouble hearing you.
I can just talk a little louder.
Okay, that'll be great.
Does that help? Okay, I'll just try to talk a little louder.
Okay.
So with photogrammetry, it's really tracing over your pattern, which creates that digital file. And then instead of drawing and finishing your pattern on the table, you're doing it, in a CAD software. So that's using 2D, fairly simple CAD functions, and then you would either plot it or you would plot and cut using an automated system that you would have in-house. That's a very basic, way of going about it, but I would recommend that is, your first step. Once you do that, just to show you a couple, again, this is going to go quick because we only have about 45 minutes. But one of the first tools that we started using when we started doing 3D is called a laser, just a laser system. And really what this does is it mounts on a tripod. There's a camera here that you can either move by hand, and it really has a red dot that would point at the location of you want to take the measurement. And then using a tablet, you would just click on the tablet, take the measurement. This also has a camera in it. So on the tablet, you could see what you were trying to focus in or zoom in on. The issue with this is that it was still a two-person job. We had some issues with a bright light and being able to see the laser. So we actually, if I step out of the view for a quick second here, I don't know if I still have them, but there are, I don't have them there, I apologize. We actually had to wear these red tinted glasses just to be able to see the laser. So it worked. It allowed us to get into 3D and start it fairly cost effective. However, now I definitely would not recommend going with a laser product if you're going to start 3D for what we do, the type of work we do, which is enclosures, upholstery, bimini tops, things like that. This is a line of sight, so you need to physically see in a straight line what you're going to shoot. There are a couple ways to get around it, where you would have to, in essence, hit a target. Let's see here. Sorry about that. So if I was going to shoot over something, I would use different targeting tools, which I would have to hit 2 points on like a predetermined ruler that I would know would go around, a surface or an edge. So this is a laser. It works. It scans. It can do a few other things, but right now, I mean, I haven't touched this probably in about 6 years. It's more of a paperweight for me now. It's an expensive one at that. So that's the laser. If you could just turn to here. This is what we currently use, which I'm sure most people are familiar with. It's a ProLiner by Protum. Fantastic tool. I travel on aircraft with it. It is a line of sight. Anybody who hasn't seen it, it's basically a pen attached to a wire. So you have the distance you pull out is, say, your X, the rotation is your Y, and your articulation is your Z. So it does measure 3-dimension. It is a point cloud. We've had this for probably, I want to say, about 6-7 years now. And this is our primary measuring tool. At first, we did start with very simple product with the ProLiner, but pretty much 95% of what we do, with the exception of upholstery, is done with the ProLiner. Even complex enclosures such as center console jobs that have a lot of pipe work, a lot of CAD building, we've come up with a pretty good system to do that simplifies it. But it is a learning curve. So 2D first, I can't stress that enough. And then you would want to, move into 3D. The nice thing with the ProLiner is I can go to a boat by myself, and it could be blowing 15 plus knots, and I can still get my measurements, my template, without hanging off the boat, trying to pattern with plastic, have the wind come up and blow my patterns away, have a moist or oxidized deck that my patterns won't stick to, and I'm on site for an average of about an hour, say half hour to an hour, depending on the size of the job. But a large enclosure with bimini, I'm on and off the boat in about an hour. Whereas a full pattern on that boat would probably take you maybe 6+ hours to do with a couple of people. So we're taking, say, a 10 to 12 hour job, and we're kicking it down to a 1 hour job, right? So 6 hours, 2 people, 12 hours, 1 person, 1 hour. Pretty simple there. It's a lot safer, a lot more predictable. We can deliver the product without having to, rely on the weather quite the same. So fantastic tool. Something I'll show you a little later. I have a new tool that we're using. We're actually very, very new for us, but it is a scanner. And I'll just quickly touch on that to show you guys kind of what that does. And I think that is going to be another tool in the toolbox. Not going to replace the ProLiner, but it will be kind of the next thing in the future. So I think that we've seen over the last several years, the industry really, really change towards, technology. And, I talk to a lot of people in the industry, and I see a lot of people going in different directions, which is fine. But their platforms that they're working with, they're kind of their starting point, the basic foundation that they're starting with doesn't exist, or they don't know where to start with. And that's a little bit what I want to show today. So for some, they might have heard me preach this in the past or talk about it in the past, but I do want to show you here a little bit about what we do, some food for thought on what you should be thinking about as you prepare to go into technology. So in order to implement these kinds of technologies, you need to have your standards in order. So what I mean by that is when you make a bimini, that bimini should be made the same way every single time. It may be a different color, it may be a different size, maybe the pockets are a different size because of frame. But your basic process, the types of zippers, where you start them and how they zip, where enclosures go and how you build your flaps, they should be standardized. If you're having to reinvent the wheel each time, you're going to have a very difficult time implementing that into a CAD process, because with the CAD process, when it's standardized, it's the same procedure. You're not having to reinvent the wheel. You just have to implement that procedure. Kind of like a McDonald's, right? At McDonald's are very successful because they have a standard operating procedure that they can train and teach anybody. And it's duplicatable, and it provides a really consistent outcome, whether we like McDonald's foods or not. Me personally, not. But that's what you really want to achieve when you're working with CAD. So we've developed and continue to develop today our processes, our standards. We have standards on how we make our biminis. We have a very specific standard on how we make our enclosures. We've created and developed and come up with our own icons or labels. So a good start would be to come up with a label plan. And I'm just going to show you, this is the very first thing that I had. Let me bring up my label plan. This is the very first label plan. Let's see if that shows. No. Bear with me here. So something like this. So everybody can see that. Let me, there we go. So you can just come up with a scratch sheet, but start to develop your label plan. What do your track ends look like? That's what our track end looks like. It's a half flag is what we call it, or a half arrow. But start to develop all your standards and come up with a label plan, how you're going to label your drawing, because you want to be able to produce that product again, or produce a very similar product or similar boat style again and again and again. Even though they're one-off jobs, we still get calls almost on a monthly basis at this point to reproduce something that we've made before for a customer because they've lost it. We've had customers that have removed and accidentally thrown out their enclosure, but you never know which one that's going to be. And when you have that callback to make something you've already made before, and you have the groundwork done, you're charging the same, your profitability is up, and you should reap the benefits as you've made that investment of technology. So a label plan is a good way to start. I'm going to pick something else here. The other thing is when you start developing your processes, I'm just going to show you a couple things. I'm going to share my applications, so I'm going to be jumping in and out. It's just going to show better for you on the screen. Here's an enclosure process.
Darren, while we're doing that, we do have one question that's come in. How much of your patterning time are you saving transfer into CAD development in the shop? i.e., does it take longer to develop your pattern in CAD versus traditional paper pattern workup? Okay,
great, fantastic question, because that's actually a little bit of a debate amongst the group, right? Because some I'll say, well, here's you can measure this console cover and develop a CAD file and cut it and sew it. And I'll talk to someone and I say, well, yeah, that's all fine, but I can do that. I can pattern it in a half hour, and I can cut and have it tabled and cut in another 15, 20 minutes and sew it in an hour. So that project you might be able to do a little bit faster by hand in some cases, but the benefits long-term of having a database of digital files that you can reproduce, because if that customer calls you back and needs that item because he's had the boat or because he trailered the boat and it's blown off down the highway, all you have to do, you're not going to the boat, you're not redoing your CAD, you pull a file and you press play on your plotter and you have an item spit out in about 5 minutes, and you can sew it in about 15, 20 minutes, let's say, well, maybe half hour. So you're talking 45 minutes of work, and you have a product that you've charged several $100s for, right? So that is where the benefit. Is that going to happen every time? No, but create that database gives your business value long-term for that repeat business and a loyal customer base. But the answer to the question, most stuff now does take us less doing it with CAD. There's the other benefit of being able to schedule your work without worrying about the weather, right? So I can go to a job site and I might have let's just say two Sea Ray 34s, full kits to do, an express boat. Well, if we had 2 people there to pattern that whole boat, may take 5, 6 hours, even 4 hours, right? Are you really going to drive to that, pattern 2 of those, and then drive back? That's a full day, right? So I can go by myself. I could do 2 of those boats on site in about 2 to 2.5 hours, right? So you've got on site 2 to 2.5 hours instead of, say, 10 hours times 2, right? So you've got 20 hours versus 2 hours, if that makes sense, of labor. And then all the work is done with a cup of coffee at your desk, right? So it's more predictable because you're not fighting with the wind. It's a lot safer because you're not hanging off a boat. Immediately, it's less labor. And in a job like that, like a 34 Sea Ray, front and back bimini, enclosure, front and back, for a full CAD ready to cut, you're probably looking about 2 to 2.5 hours in CAD time. Another maybe, what, Rebecca? Another half hour in you think? So maybe another half hour in detailed sewing instructions. So call it 3 hours to plot and cut something like that. By the time you pull the fabric out and stack it ready, maybe a half hour, 45 minutes. We're talking a full enclosure with 2 biminis, and then you sew it and install it. The thing with that is we're also patterning, or measuring, should I say, the entire boat. We're not patterning a bimini, then making the bimini, coming back and making it, then going to the boat, taking his old stuff down again, putting the new bimini up, pattern the enclosure, right? Then take the new bimini down, put his old enclosure up, come back to the shop, make everything, and then go back and install it all. So we also have a one-trip reduction. So I don't really have a precise answer for how much time savings there are. I can tell you that on a job like that, I'm probably saving about 20 hours. I would say 15 to 20 hours on a job like that. From a material standpoint, with the ability to nest and know exactly what I'm going to need and only order that, I'm reducing my material costs. When we first implemented, I know this number is very accurate for us. It was about 32% savings in material usage because I wasn't doing a rough order where I maybe had 2 or 3 yards left over, or I under ordered where I had to order another yard or 2 and also pay for that secondary shipping. So there's a lot of other variables that go into that, but kind of a long drawn out answer, but there are a lot of variables, and I think the time for 80% of what we do is considerably less using the technology. So this is a quick cheat sheet that we use for our enclosure process. This is a very basic cheat sheet. It's actually an old cheat sheet. We have a more updated one now that's embedded into CAD. But these cheat sheets are actually, you can see me there, in a binder. So they're just here that as we go through, they're laminated. We can check them off. I can write a note in there. They're just in a binder here to follow through. Also, the cheat sheets can be secondary in a Word file next to your CAD file. And I don't know if you can see, I think you can see from my screen, we've got a very large curved monitor here. It's actually, it's like a join two monitor. What's nice is we can manipulate the screen if I want a very large CAD file and just a small area for instructions or for these, for the process that we follow, then that can be done that way. So let me share another file with you real quick. This is just, it's very similar to the last one. This is just another, this is for a 3D process. So the first one I showed you was just a general enclosure process. This is a 3D process that we would utilize on a very high level, just to make sure our process is correct when we actually go through our flattening software. Okay. Let's see. Now, this next, the next item I'm going to show you here, this next form, is kind of been a lifesaver for us. And this is something that everybody's going to want if they don't have it already. It took us a couple of years to figure this one out and get it right. But this is just my CAD check sheet. This is my operating plan. When we go to a boat, when we're down working in CAD, this is what we're checking. I hope you can you see my cursor? Let me go to another computer here for a second. So the top portion here is really verifying the order while we're on the boat, and it's verifying what's on the boat. And this is used for 3D. So when we're using the ProLiner, you don't have a pattern to write on anymore. You don't have that same, I guess, integration with a pattern. So you don't know where you were, and you don't know, it's easy to forget something, I guess is what I'm saying. So we'll obviously confirm the color. Excuse me, we'll check the box off. When we get into CAD, the CAD check is to make sure that that information was also put onto the instructions and confirmed once again. Frame diameter, if we are doing a bimini, we'll circle that, note it, make sure it was checked. The type of snaps that we're dealing with, top border size, you know, if we're trying to match an enclosure or there's a very specific, you know, on our patterns, we would draw that top border size generally. Or we might make a measurement down and say, okay, we want 3.5-inch top borders. But when you have the ProLiner, you can't just sort of scribe something in the middle of the air, even though, I mean, you can do that with the ProLiner, but it's hard to measure and free float that. So if you have a good check sheet, you can answer all these questions, and that's really all they are. They're a series of questions that you need to answer while you're on the boat so that when you get back to the office and you sit down in CAD and you have a question, well, wait a second, are there reinforcements? Or where are those chafe bands? Or what is the border size? What were those snap types again? I forget. It should all be answered in this upper portion. The center of the page is a, you know, pipe and zipper locations, you know, letting the designer who's doing CAD understand or know that there may have to be single pole sliders to the outside, right? So that's sometimes hard to interpret when you're in CAD, but on the boat, those questions should be answered. And then of course, the bottom are final CAD checks, which are critical. So I follow a 2-check point. One is that it was physically checked, and the CAD box is that it was actually implemented into CAD. Okay, so it's important to have, I think, the 2 checks. We found that's very successful for us. It works very well, and the idea is that every box should be checked. I'd be lying to you if I said we checked every box all the time. Not following my own procedure got me into a stressful time. We produced a full rigid enclosure. It was like a 58 egg harbor. Went to zip it on, and wouldn't you know it, the whole entire closure was built inside out. So that was a stressful Friday, right? And it was really because I did not do a 3-second check in CAD. When you have a model, a 3D model, you can type a command just called DIR or direction. So you can select that model and hit direction, and it'll give you a bunch of arrows. And really what you're doing is you're checking the direction of the model. When you flatten that model, you need to know what direction it is. Are you looking at the inside or are you looking at the outside? And what had happened with this model is I didn't check. It flattened to the inside, which is how we work. But normally it flattens to the outside, and then I would flip or mirror that project. Because I didn't do my direction check, the entire enclosure was made inside out. So we're talking a 3-second command to save a week's worth of work, right? So those checklists should be your almost like your flight checks. An airline pilot, they do flight checks every time, right? They do not take off without those flight checks because of the high probability of an issue. So the high probability of an issue, if you do not do your checks, right, you will have. So best just to stick to those CAD check sheets. Come up with them on your own. They'll be, depending on what you're making, but they are absolutely critical for what we do. Any questions on that?
And we have another question. What do you use if you need to fabricate a frame?
So if I need to fabricate a frame from scratch?
Apparently, that's just the only question I have. If you want to, whoever typed this, if you want to type some clarification, just what do you use to fabricate a frame?
Well, we don't. So we'll fabricate a frame, like physically fabricate the frame and then put it on the boat and measure that.
They're saying from scratch. From scratch.
Well, if it's from scratch, I mean, I'll go to the boat. I'll take a couple of typical measurements. I'll fabricate the frame in the shop and then go back to the boat, install it, and then at that time, I will, digitize or proline that frame. If you're talking about physically building the frame in CAD, we do not do that. We don't do a lot of framework, so we're not really there. It doesn't pay for us to really do that yet. We do add the odd frame here and there. We are looking at a couple of projects where he wants to add a frame for an extension, and that would be simple enough to build that. We could measure for the frame, is the way I pictured doing it. We haven't done it yet, but the way I pictured it, we'd measure for the frame on site just with a tape measure. Then we would build the frame here. We would digitize the frame, and then we take that digitized frame and drop it into our 3D model and then build the surfaces continuing for that project. And I know that can be done. So frames from scratch, but they're just done traditionally.
And Darren, are you willing to share copies of your checklists?
I can do that if you kind of send me a message. You can get, you can just call my office, Nautilux Canvas. Just don't call now. So, but call the office anytime. We'll chat, and I can share some of that stuff with you. So I'm going to show you something that Rebecca, who does our CAD work here, has started. This is a complete work in progress. So she edits this as she goes along. I guess I should share this with you, right? Because you can't see it. All right, here we go. Okay, so this is our an enclosure process that, as Rebecca's learned our style of doing things, she's been documenting and creating this whole process. And as she does CAD files and realizes there's something or comes up with something that's a little different or varies, because there's so many variables in what we do, she will implement this and make that addition or change. And so the way she operates this is literally just to the side on the right hand side of her screen while she's working on CAD. So she can scroll down, follow it, but it's very, very extensive as far as, and this is just for doing an enclosure. She has some examples. And then sorry?
It's not following you just as fast.
Okay, it wasn't following slow there. So she has a few examples, and then up here, I don't know if you can see it, she's just taking the snippet tool and she's snipping icons. Like here's an icon for exact flat. So when we use, for our flattening software, we use exact flat. We find it's so reliable. We just don't have any issues. A ton of confidence in it, and great success with it. So you can snip these little icons and bring it into a Word file here really easily. And I'll give Kyle Van Dam kudos for showing me a little snippet tool. Thanks, Kyle, when he was here. So by creating these processes, and this is it takes a few years to get this, and it's constantly evolving. You just have to start somewhere. You have to start at the basic, and I think those, like I mentioned, your label plan is your basic. Start with there, and then get into the proper process for developing a file. Okay, now what I'll do is I'll show you a couple of, these are all things that Rebecca's put together. Bear with me, sharing. Okay, everybody see that okay? So this is just a block file. And this block file, she's sitting here right here with me. This is so she'll correct me if I'm wrong. This is kind of a work in progress file.
Absolutely.
Okay, so this is what she's doing is she's creating blocks and instructions, which I'll show you later. But she drops these into our sewing instructions. So these are cross sections of Ketter and different variables that you may have, how a Ketter welt will be applied. We're also using hex colors. We've just come up with our own hex colors that represent, it's a very specific color, but it represents, say, a zipper or a Ketter welt or a hook Velcro or a non-separating zipper. And I don't know how many colors you figure we have, Rebecca, maybe 30, 40? Yeah. So we're using color codes because when we present our documents to the floor, you don't want to read a whole bunch of things. Or maybe you have different languages that are spoken in your shop, but everybody understands colors and everybody can learn the colors. So that is a great way to implement sewing instructions onto the floor. So Rebecca just constantly is evolving this on how to provide information. You know, we call, let me zoom in, hopefully you guys can see this. So bead, groove, and flange. So when we pattern, we're always patterning the groove, for instance, you know, or we're measuring the groove. You know, come up with your own terminology. She's come up with a couple, these are kind of cool. Hook and loop Velcro symbols. And then going along. Oh, those are for biminis or some custom stuff. And now we have some webbing components. So depending on the type of buckles we want, D-rings, for instance, or a type of buckle we want sewn, she's come up with these standards, right? So the standards is a 1-inch side release buckle, you know, with a 1-inch box stitch, with or without a hook. So you develop your standards, and then you can apply this to, say, a center console with wings that go out and connect those wing panels to the gunnel. Those buckles should be the same every time. Why should they be different? So the for those buckles should be the same. These are for some Palm Beach covers, you know, with the bungee cord that would go through a grommet into the tow rail of a sport fish boat. So these are just some details on that. And the idea for this is to basically grab this and drop it into an existing file that she works with. And then just to show you something very basic, this is how to sew a half moon reinforcement that would get just simply a web loop for, say, a winter cover. But it's funny when you really look at it, it's simple, right? But if you start dissecting it, there's a lot of questions that you would need to answer. Does that patch get sewn inside or outside? Does the webbing go inside or outside, right? When does it go on? Does it go on first or does it go on last? So, and then sizing. So just for that simple cutout, it's kind of amazing on how much detail could go into that. So just start with simple things that you can develop, and it will just constantly evolve. But you got to kind of keep up with it. Just constantly evolve it. All right, so that's that. I'm going to show you now. Let's see here. Bringing up another CAD file. Just takes a moment.
While you're pulling that up, we do have another question. How do you compensate or calculate for the bimini frame deflection or bend at the middle or center of the bimini? Do you tension or preload the frame on site, or is there a calculation in the software?
Great question. An important one. So when you're patterning, you can see what's happening with the frames. When we would pattern traditionally, we would preload the frames front to back, and we would, take our template. We do it exactly the same way with the ProLiner. But there's another variable. When we were patterning by hand, there's only a few people, I know Kyle is one of them, that'll actually pattern an entire boat, right? But when we would pattern by hand, we would do the bimini first, and then we pattern the enclosure, right? So when we pattern the enclosure, there's a little bit of a downward pull. So with the ProLiner, since we are patterning the entire boat, we preload the frames front to back. But then what we found works very, very well is we'll draw those frame, like the front frame, let's say, we'll draw that frame and load it down, put weight on it as if the enclosure was hanging there, installed, right? So forgetting to do that could completely screw up an enclosure that has a Venturi windshield that goes over, because when you go to install that, just the weight of those panels could drop the bimini frame, ½ inch, 3/4 of an inch or more. And then now you're going to add tension to that. So sometimes on smaller frames, depending on the projection, we can get almost a negative in the frame when you look at the top view. So we do preload quite a bit. And then our drop down, so we did a Sea-Ray 40 sedan bridge recently. And I'm trying to remember, I think our pull down on the front was probably 1.5 inches, where the frame was sitting stagnant, as opposed to then strapping it down on the front. So it's pretty substantial pull down, but what we find is the enclosures they go on golden, or smooth as can be. Every once in a while, we do have a little adjustment, which is normal, but we're at the point where we can go to a boat, it's very predictable, unless it's something catastrophic, like my error in not following my process. Generally, if at all, the alterations are quite minor. So, but yeah, great question. We do preload the frames, but what's different is we also put down pressure to pull the frame down in the direction of the enclosure. So these are some quick, simple examples of what you guys could come up with for a bimini cheat sheet. So this bimini cheat sheet is, when you're doing CAD, you need to know that you offsetted this line to that distance. We measure it to the center of the frame, let's say. So the offsets for us, if you're on mid bow, would be just ½ inch for seam allowance, right? But you need to know that when you go in here. So this example is actually for traditional pattern, and it's just based on how we would traditionally pattern. We don't pattern the middle of the frame. We ProLine the middle of the frame. When we pattern, we're actually patterning to the inside of the frame, if that makes sense. And so that's why this intermediate area, we're adding 1 inch. 1 inch to get to the middle of the frame, and then plus seam allowance. But you want to have a good plan to follow. And this is, again, your standard operating procedures. This is the same for every bimini, but you can just follow this procedure. We have a little different procedure when we're doing a ProLiner job. And these instructions, they're similar, but the offsets are a little different. So again, what you do by hand with the traditional pattern, that is your process. You just have to document it. Once we get over, this is just an example of a bimini. It kind of shows the components needed. This is, I believe it's embedded in the file now. That stays with the file. It just lets the CAD operator know that there are pockets, there are intermediate pockets, there are reinforcements, there are double layered forward and aft flaps. There are, we mark all our zipper starts and ends. I should slow down. I think the computer has a little lag. So these are showing match marks and our zipper start and ends. The long vertical line there is actually the panel break, to show you that. So this just, again, is something to follow. You could have a lot of scenarios embedded in your file to follow. You just bring the scenario that applies to that current job that you're working with. So, compile these scenarios. I know, like, for instance, Clint and Justin and they use a lot of blocks and templates. So you can create a template, which is just saving a Rhino file as a template that's a read-only. And you would open that template every time and work with it. Everything's in there already. So they work really well for doing repetitive or very similar items like a Bimini. Okay, so that's the Bimini offsets. Okay, let me bring up an enclosure real quick. So this I'm going to show, this is just an enclosure we actually have on the table right now. She's just finishing it up. And this, I just wanted to show you a fairly simple version of what I was talking about as far as the coloring schemes. So this is our true file that Rebecca had finished, I don't know, this week or last, and she cut it the other day. Now, when this is a 3D file, we do work left to right. Technically, it's not correct. You should work diagonally, but it's just the way I feel more comfortable. We don't really have an issue working left to right, but you work diagonally because when you are in your perspective view, that generally you're looking down the side and everything's in the way. So if you are diagonal, right, everything's kind of stacked away from you. Again, for me, it's not technically the right practice, but whatever works for you guys and what you're comfortable with, just stick to it. Stick to the same kind of thing. I think my computer has a bit of a lag to it. I'll just try to show you a few things. This is just the model being worked through, right? And then I'll go back to top view. I know I'm just going through this quick. And what we do, which actually I should have touched on first, is we have this title, kind of this title line that we like to follow. And where it says layout and final, that just wasn't, let me zoom in here. That works, layout and final. All these titles are just stacked initially there. And then as we build the model, Rebecca would grab the title and drop it where it applies. The idea, the way we use these, the idea of these titles, they're kind of the last command that was done. So where it says mesh, right, I created a mesh for that model. That was the last command that was done before I copied over, before she copied over. And notice how many copies we have. Because as you go through a process, some of these stages have a lot of work in them. And you don't want to necessarily lose that work or overlap that work too excessively. So pause, copy over, and then continue. Because in your continued process, if you make a mistake or there's something catastrophic, you can just back up a step. So stage everything strategically. And then again, these titles also help us with, here's a good one that I should, again, checking direction and knowing we mirrored it to the inside. And then as it progresses through, she'll have, layouts and things like that. So what we do for the sewing instructions is basically this. So she's got some information here. Do you have the large printouts for this? They're here? Okay. She's got all the information that applies to those three panels in a color code so that it's easily recognizable. Now, in Rhino, those lines don't show up really. They're just fine lines. But what we've done is it's something easily done in layers that in the print preview, in the print kind of side of things, they actually print quite fat. And just to show you what they look like,
It's not the exact one.
This is a different. And what we also did is with this information, you can see me with this information. We found that printing out 5.5 by 11 was very hard to read, and that's kind of what started us on this color thing. But there's a lot of detail that you cannot see in those 5.5 or 8.5 by 11s. So what we started doing, I don't know if you can see this, so we bought a wide format plotter or just a printer, and now we print on a large format because all these details, and this is printed a little large so you guys can see it, but all those details are on here, even like small details like zip starts. And when you get into a file that's on an 8.5 by 11, as far as that spec sheet goes, very tough to see match marks or a small detail like a zip start. But on the large format, works very well for us. We can make any changes on here and then implement it into CAD when the job's done. So that's kind of showing you real basic on what we do as far as these, these color codings. Again, the webbing detail is in here. Anything shaded represents reinforcements of a specific type. So again, the idea is that this map, as we call it a map, or a sewing plan, goes to the floor with the work order, and all the information that the sewer would ever need is there. Okay. So I'll show you another one dealing with the bimini. Sorry. Okay. So this is a bimini map. Let's see if you can see it. That way. There we go. So that's a quick bimini map. Shows what's reinforced. Has some real specialty stuff on it as far as zip starts. There's a couple things that were noted on here by hand, and they will be updated in the CAD file. But again, just to show you that. And as opposed to doing a 8.5 by 11, that you just can't read. It's just too busy and not big enough. So there's a lot of things that overlap each other. There's a lot of information that overlaps and gets lost on the small sheets. So even though they're a little cumbersome, they're actually working, very well for us. The other options, you could just put tablets on the floor, and then someone could have access to the drawing. But again, they can't. It's harder to write on. I like the touch and feel, so that works really well for us. And developing your CAD files, just to show you, for those that are, even those that are just starting out, to show you really what they develop into. This is a job that we're currently working on. It's not done, but just to show you the model on it. And this just takes you to a little more of a full, a little more complex 3D model, dealing with some pipe work and things like that. And it can be overwhelming at first, but it's not that bad. So this is actually a custom, I think it's a 47. It's like a commercial fishing boat without the commercial mess. It's actually a pretty nice boat, 47 feet, pretty new. So we built the pipe work for this all in Rhino, and we built the model. So from this point, we're going to have to flatten, get our view lines and things like that. And our view lines, he wants all this stuff to match up with the pipe work. So, it just kind of shows you what you can do with some of the modeling. And to give you an idea, that pipe model probably took me about an hour to put together. So really not that bad. The nice thing is you can present this to the customer, right? And then they get a really good sense. All right. Last thing I want to show you guys is, let's see here, is this scanner, because we're getting close on time. Actually, for that stool. Thanks, Becca.
Actually,
So
we're
this is
actually just about out of time, Darren. So if you can finish that up.
Yep. I need like maybe 2-3 minutes. That's about it. So this is a scanner, the Artec Leo. It's a light structured scanner compiled with a camera for textured and color. And really quick, this is just a teaser. I just want to show a little bit about what it can do. Well, I should have turned it on earlier. Just takes a moment. So it's got a touch screen on it. You can flip out depending on the angle. Takes a moment. And what this will scan, it's actually designed for reverse engineering. Let's go. We'll go to new project. So you can see it's got kind of a light on it. I've got a trigger. And let me see. I'm going to just quickly try to scan this. Come down to the, so I'm just going to scan. You can see on here, let's get a little closer. You can see on the screen, I don't know how well you can see it, there's some color coding. So I'm just going to scan this. Careful not to get my boots in here. But you don't have to scan the whole item. You have to scan the high spots. So think about if you're doing an enclosure. Let's see if you can see that. So kind of cool, right? So this is new scanning technology. And really what it is, that's good. So that scanner, you can scan something and you don't have to scan everything. It actually scans into a mesh, which is very easy to work with in Rhino. So imagine scanning a seat or let's say a console cover or a pedestal in a boat, something small that we all have worked with. You could scan that pedestal. Now it's like working digitally with that real live pedestal. You would draw a framework over top of it, showing, say, where your seam lines are, and then you surface it. If you surface it, everything should be inside that surface, and your cover's good. You just have to break it out into your structure before you surface it, so you're getting the right shape. But quite easy to work with. The difficulty with this is processing. So you need a very powerful computer to process it. We process it with 128 gig RAM computer. In some projects, really what you're doing is you're processing the information to simplify it so it's easier to work with. I think we're pretty much out of time. I crammed a lot in there. I hope it gave some people some food for thought, some things to think about, and hopefully some things to help you guys plan.
Great. Thank you very much, Darren. That was a lot of great information. I know we didn't have a lot of time. Darren will be hanging out in the chat rooms later on. So if you did not get your question answered, definitely seek him out. I know he'll be happy to help you out with that. So at this time, we're going to move on to our exhibitor spotlights, and our first exhibitor to speak to us today is Craig Zola from Herculite. Craig, would you like to join us, please?
Yeah, hi. How's everybody doing? Hey, Charlene.
Hey.
Hey, it's really great to talk and see everybody on video. I'd like to thank Aaron and Barbara from IFAI for putting this event on. They're doing a great job, and it's really the best we got with what we have to work with. And Darren, that was a fantastic presentation. I'm sure that everybody has a lot of questions. I kind of feel like the guy that starts his act after happy hour and all the prices go up. But that said, I'm going to share my screen and I'm going to talk a little bit about Herculite and Strataglass. Herculite acquired Strataglass in 2015. And I'm looking for my screen. Here we go. So about 6 years ago, can you guys all see that? We acquired Strataglass, and today I want to talk a little bit about the company, about our product, and what we do to make it the best product on the market. First, our mission at Herculite. Our mission is to help our customers grow their business by delivering products and services of exceptional value and quality on time every day. And we feel that if we accomplish that, they reward us with their business. And we appreciate that business. We also believe that quality is really an attitude in our company. It's about product, speed, flexibility, teamwork, and attention to detail. Most importantly, it's about how we view our obligations to our customers and how we respond to our customers' needs. Quick mention about something that typically goes under the radar at Herculite. We do have programs where we help the community and we give money to different charities. We also have programs where employees will, the company will match employees' donations to various different things in our community and around our industry. The United Way of York County is one, Big Brothers Big Sisters, and of course the Industrial Fabric Foundation. So I just thought I'd mention that. Our brands at Herculite, this is our menu. We make products for the awning industry, the marine industry, digital printing fabrics for banners, tent fabrics, healthcare, and also custom and performance fabrics. But today I really want to specifically talk about Strata-Glass and Crystal Clear and what we're doing in Fort Lauderdale at that plant, where we're press polishing clear vinyl for marine enclosures, something that is near and dear to everybody's heart on this call. We feature the View Shield scratch-resistant coating at Strata-Glass and also a 2-year warranty against degradation. The product features excellent clarity and durability. So what is a press polishing process? Basically what we do is we take raw material, raw clear vinyl substrate, we put it through a process of heat and pressure through platens and chrome plates. And here you'll see kind of a sketch of what happens is we remelt the PVC back to a thermoplastic, which the internal stresses and orientation of the polymers. And then we refuse it and brings it back to one sheet. So we can take several layers of raw material, put it through the process, and when it's finished, it's not really considered a laminate. It is really a one-ply product. So what does that do compared to traditional clear vinyl? Extruded clear vinyl that's made on a roll is a continuous process that it's a good product. But really what happens is you end up with a not so clear product. The extrusion coated roll vinyls tends to scatter and bend light, so it's a little bit more blurry. The thicker the product is, the worse that clarity is. And it also comes with it a shrinkage factor. When you put the clear vinyl through a process like our process, where you press polish the clear vinyl, you maximize the clarity of the clear vinyl, and you also maximize the dimensional stability because you take all of the stretch out of it. So that, you bring your product to less than 1% in shrinkage, you've got a very dimensional product. 5 points at Strata-Glass that we go through in quality control. And I bring this slide up because there's certain expectations that everybody has, from the consumer to the fabricator, about what is acceptable as far as quality. And, the standard, of course, is perfection, which is a standard that we can never meet. So with these 5 different parameters, this is what each sheet has to go through in our process. And the first is a lamination quality, where we actually take the sheets and we pull and make sure that we don't have any separation. And we take a cross section and we magnify it to make sure that the lamination is good across the sheet. The product has to be perfect within a 2-inch buffer around the edge. And if there's any areas of the sheet that go beyond that 2 inches from the edge on a lamination, it's rejected. The next thing we check is clarity, and we have a machine actually called a Zebedee clarity meter that we hang the sheet in, and we measure the clarity of the sheet using light. And there's a tolerance there of 60 milliamp wavelengths that tells us that the clarity is acceptable. Anything below that is rejected in clarity. Third is contamination, which is a visual inspection of the sheet using light. We're looking for small debris that might have gotten into the sheet, drips of oil, even human hair off of people's arms, anything like that can be detected. And if we find any kind of debris within the sheet, it's rejected. The fourth parameter is cracking, and cracking occurs to our coating on occasion, where the actual coating during the heating and the cooling process folds over and creates what looks like a little fisheye. We call that cracking. It used to be a big problem before we acquired the company, and we really made that problem go away in the last few years, but it's still something we check for. And lastly is the sheet thickness. We want a consistent product and thickness, and we use a digital micrometer on the sheet in 9 different parts of the sheets to make sure it's within our tolerance. And of course, if it's not, it's rejected. So why Strataglass? We feel like we have the best scratch-resistant product on the market. And several years ago, we put that to test, and we had our guys at Herculite put together an in-house testing procedure where they take a 1 pound weight and they put it on a shuttle with a piece of steel wool, and they scratch or basically rub the steel wool over the product several times to see how it affects the coating. And so the results of that test are that on the left there, you'll see Strataglass after 20 passes, you see no scratching from a 1 pound weight with steel wool. We took our competitor's product and we did the same, and we ended up with a product with a situation where you could actually see scratches after 20 passes. And the real exciting thing was after 100 passes for Strataglass on the right there, you could see that we still don't have any scratches. So we're really confident, and we're really happy that our technology and our coating is what you need it to be a scratch-resistant product in the market, especially in the marine environment.
Craig, one minute.
Lastly, the warranty, it's a 2-year warranty against actual use of the product. The warranty is designed for your customer, the boat owner. We ask that you or the boat owner goes online and registers for the warranty. There's a simple page on our website to do that. That validates the warranty, and we have had this program in place since 2017, I believe. And we really have yet to have to go through the process of replacing anything through the warranty process. We're proud of that fact. Lastly, I'll leave you with a slide about care and cleaning. We still endorse the IMAR products. They are the copolymer blends perfectly with our products for cleaning and polishing. And if your customer wants the product to last more than a few years, you got to teach them how to take care of it with the IMAR products. And with that, I want to thank you for your business and your time. I'm not sure if there's Strataglass in that picture, but it looks like a fun place to hang out. Thank you very much.
All right. Thank you very much, Craig. All right. Our next exhibitor spotlight is Steve Fredrickson from the Sattler Corporation. Steve? Are you there, Steve?
Saw the button at the very end.
Hi.
Yep. Thanks, Arlene. Thanks, Craig, for starting it off. It's good seeing you again. Of course, it's the year of COVID, and that means we're meeting in a very unique way that, frankly, at the beginning of the year, if you think back at it, March, April, to be able to have 60 some odd manufacturers, fabricators in a room virtually seemed almost impossible. So kudos to MFA, to the various divisions of IFAI for making this happen. I know that we all appreciate the opportunity to get together, even sometimes over a webcam. It is more than we've had for a very long time, so it's good to see everybody. My name is Steve Fredrickson. I am the sales director at Sattler. I've been in this industry since 1996 with various distribution, manufacturers of final products, as well as selling fabric. I've been with Sattler a little over 2.5 years after 17 years at Ferrari, which is probably where most of y'all know me from. Who is Sattler and why did I join this company? Sattler is a 145-year-old fabric manufacturer. Really what it boils down to is they're a manufacturer, of solution dyed acrylic fabrics. Those are used in a lot of shade applications in Europe and then around the world in marine applications. We are present in over 90 countries around the world. And in 2011, we purchased Outdura, which is in Hudson, North Carolina, which is where I was yesterday. That's the plant that produces all the casual furniture fabrics that we have in our lines, as well as our 16-inch solids. I thought about a lot of different things to talk about from a fabric standpoint, or what we do this or we don't do that, or even a PowerPoint presentation. And I decided most people, me personally, I use that time to go get breakfast. I use that time to go do something else. And if there's somebody standing in front of you, it just makes it a little bit harder to go do something. So what I wanted to tell you is probably the news you guys mostly heard about based on the number of text messages, phone calls, and whatnot, and the industry gossip machine was going on yesterday. And that is, yes, I would like to welcome Mike Winsky to the Sattler team. He has been a longtime industry expert, and we're excited to have him join our team. And as I said, with Sattler, 149 years in the industry, when I calculated it out, we have 120 years on my sales team on just the awning and marine side. So having Mike join our team is a lot of industry expertise joining, and we're excited to have him on board. He'll be in the Southeast. He's here virtually right now. So if you want to come by after and talk with us a little bit, I'm sure you guys can find out the full scoop as much as he wants to talk about. We'll be happy to talk about fabric, which is what I will now talk about real briefly. Two products. One is the Trio. Trio is a solution dyed acrylic that is from our 60-inch range. It's available in 6 colors. And what makes this interesting is we add a backing headliner that's very, very soft, can be used on teak, a variety of gel coats, very fine, expensive furniture, frames for covers. Provides 100% waterproof protection and is breathable. So give us a call, let us know what kind of things we can do there. I can certainly talk about the Outdura. I can certainly talk about the most popular product range out there, modern textures. I can talk about Ovation 3, but if I was to talk about Ovation 3, I wouldn't be talking about what is now current. Ovation 4 launched about 10 seconds ago. Officially, catalogs are available. Books will be available in April, but we have fabric on stock, and it's available for cut yardage. So this is a product very, very common. I'm sure a lot of you guys know about Outdura more than you know about Sattler. And so come on by, give us a holler. Happy to help. Look forward to talking with everybody. And just want to say thanks to all those who attend these events. I want to say thanks to some people call them competitors, but I call them partners, friends of the industry. I know the two guys that are following me up, Mike and Dan, are great guys. I've known those guys for decades as well. And just personally, I look forward to, doesn't have to be with a drink in your hand, but I look forward to seeing everybody in the bar soon at some place, somewhere, wherever that may be, in person instead of over one of these webcams. So thanks again, y'all, for coming out, supporting the industry. And me and Mike and Todd and Julian will be in our booth or near it with our head shots and whatnot, ready to talk. So that's all. Thanks, everybody.
Great. Thank you, Steve. All right, so we are going to take a very, very short break. If everyone needs to make a potty run. So if you can be back on at 4:35, we are going to continue with our exhibitor spotlights and then shop tour after that. So please be back at 4:35 and wrap up your conversations right around that time. Okay, see you soon.